Here's another installment of Pivnert, the ideal gas law. Using this equation, do an example problem on this video, as well as go into a little bit of the chemistry behind it, some of these connections between physics and chemistry. Here's the equation. Of course, just a little review. P is pressure, V is volume, N is moles, R is the gas constant, and of course T is the temperature. Okay, so we'll be using this equation for this video. Here's just a sample problem we'll be working through here. An example problem. Read it to you. A sample of hydrogen gas has a volume of 8.56 liters at a temperature of 0 degrees Celsius and a pressure of 1.5 atmospheres. Okay. It says calculate the number of moles of H2 molecules present in this gas sample. Okay. Before I start getting into this problem, I just want to explain this here. If you notice, the words in the problem have hydrogen gas. Okay. Of course, there's a periodic table. Hydrogen is an element on the periodic table. Okay. And one thing you might also notice is that when it gives the molecular formula to you, when it asks for this question here, it gives it as H2, right? This subscript 2, meaning there's two atoms of hydrogen that are actually bonded together, and it doesn't say calculate the number of moles of hydrogen atoms, it actually says molecules. Okay. There are some atoms that don't exist under natural normal conditions here on the Earth, especially as atoms. They are called diatomic molecules. They like to bond to other things. If there's nothing else around, they'll bond to other atoms of the same element. Okay? Hydrogen is one of those. It's really easy to memorize these. You can memorize them right now. Here's the periodic table. We have what I call them the heavenly seven. That's how I remember them. Heavenly seven. Okay. Most of them are gases, so heavenly makes sense. That is what heavenly. Heavenly seven. If you can remember this H from the heavenly, and you can remember this number 7, you can memorize these. And you can also carry a periodic table around your wallet like I do. So here's how it works. There are 7 elements that undergo this. Okay, the H of course stands for hydrogen, so hydrogen is obviously one of them. So that's why I call them the heavenly 7. Got this from some old colleagues of mine that were good at coming up with ways to memorize things. This is really cool. The other way you can memorize this, so heavenly is for the H, 7 helps you where if you go to the 7th element on the periodic table, that is nitrogen. Okay, so if you begin there, 7, and you actually can draw this out, or these elements, actually the elements that are diatomic, the heavenly 7, make a 7 on the periodic table. So these hydrogen, there's 7 of them, they make a 7 on the periodic table, and they start after hydrogen with the 7th element. Okay, so the 7 is kind of the magic word for memorizing this. 1, 2, 3, 4, 5, 6, 7. Okay, makes a 7 on the periodic table, starts on the 7th element. Amazing. That's why this chart is my 3rd favorite chart that's been made so far. Okay, back to the problem here. So where it says hydrogen, if it was substitute for nitrogen, oxygen, iodine, any of those, when you see this word in chemistry, this name of this, it does not mean H, it means H2. Same thing for nitrogen, it does not mean N, it means N2. Okay, so it forms these molecules. All right, so let's label what we know here. Mark this up. We have a volume of 8.56, so V equals 8.56 liters. We have a temperature of 0 degrees Celsius, so our T would be 0 degrees Celsius. Of course, to use this, it still follows through. This has to be in Kelvin, so that would be 273.15 Kelvin. Really easy at 0 degrees to convert that. And our pressure is going to be 1.5 atmospheres. And so we are looking for the number of moles, which of course is N, is our unknown. Okay, so here's our equation, PV equals nRT. So I can manipulate this, PV equals nRT. For my unknown, divide both sides by RT to get moles by itself, RT. Okay, so the R cancel, T's cancel, okay, by itself, so we have just moles, so there's our equation, okay. Might be a little bit more review here, but the R here you want to use as your constant, of course, which is in atmospheres. Last video I did what it would be in kilopascals. So for atmospheres, so a side note here, this would be R would be equal to, if you solve this the same equation, PV over NT, right? Hopefully you've already done this on the problems, but this will be a little more review. Where if you plug in the standards, 1 atmosphere, 1.00 times 22.414 liters, and divide those by 1 mole, 1.000 moles, and our standard temperature, 273.15 Kelvin. Okay, and so if you don't remember what this is, just a little quick review. Plug that into your calculator. That would just be 22.414 divided by 273.15, really small number here. So the constant is 0.821 is usually the used one. So R would be equal to 0.8221, and of course the unit would be atmospheres times liters per mole times Kelvin, okay, or atomoles per molk, I like to say. Okay, so that'll be that's a R, just to review that with you again, just where that comes from. Okay, so here's our values. So now let's plug this in here. So we're going to have our N is going to be PV divided by RT. Okay, so unknown N is equal to P, which is 1.5 ATM per, or times the volume, which is 8.56 liters, divided by R, which would be, of course, our constant, 0.821 atmospheres times liter per mole Kelvin. So let me just jot on a couple more, just so you can really get a clear picture here. So our atmospheres or liters will cancel there. Per mole Kelvin, so it's in our denominator, so it's going to flip it up here. So mole, right, times Kelvin, so you can see that in the blue part there. And then divide by the temperature, which would be 273. Put that here, 273.15 Kelvin. Okay, so you can see some things canceling here. Atmospheres, atmospheres, liters, liters, Kelvin, Kelvin, go away. We're left with moles, which is what we want. Okay, so plug this into your trusty good friend here. 1.5 times 8.56 divided by 8 point, oops, it was 0.0821, I believe. So notice a mistake here. This should be 0.0821. My 0.0821 atmospheres per times liter per mole. Just so we don't mess ourselves up here, let me just correct that. Very important to be able to read correctly off the calculator. Very easy mistake to be made. So 1.5 times 8.56 divided by 0.0821 and then divided by 273.15 gives us a new, the number of moles is a little more than half. So and number of moles would be 0.5. Let's see here, two singular digits, 0.57, 0.57 moles. So there's just an example problem to help you. Now you can try some of those other problems. Next video I'll do show you how you can get mass, you can get density, get some different variables. We'll do some mathematical manipulation magic. Mathematical magic, as I like to call it. So until next time, have a nice day.